Alright, so let's take a look at today's lesson. What we're going to be talking about is arc length, latitude, and linear speed. Those are the three concepts that we're going to be working with today. So let's start out with arc length. For our arc length, you probably remember from geometry, you calculated arc length in geometry, but typically you would have used like a degree measure or like a portion of the circle, like you had a fourth of the circle and you'd multiply that by the circumference. Remember that? I mean, yes, that is a way that you can find arc length, but in pre-calculus and trigonometry, we have another formula that's pretty handy. This is our arc length formula, and basically they use S for arc length. For whatever fun reason, it's an S. S means arc length, and the formula is S equals R radius times theta, and theta has to be in radians. That's just a bit of a caution there. Many times you will be giving an angle measurement that's in degrees, but in order to use this formula you have to convert from degrees to radians. Okay, just keep that in mind. The formula works only with radians. Okay, and so that's going to allow us to find, like this arc length of the circle. Okay, we okay with that? So that formula is a formula that you will need to memorize. There are several things that you need to memorize. So what I'm helping you, on the long term, you're going to be in calculus next year, and on the calculus test there are no formula charts. You have to remember everything. You have to memorize everything. So we're just going to work on our memory. Memory work. We need to, and I'll let you know which formulas you need to memorize. That's one of them. You need to know what the arc length formula is. Alright, so now let's take a look at our second topic, which is latitude. We're going to use some application problems that have to do with latitude. So the latitude is the degree measure of the shortest arc from that point to the equator. So this central angle, we'll just call this theta. This degree measure right here is our latitude. Okay, and it is in degrees. They do degrees, not radians. If it's followed by an N, that means it's in the northern hemisphere, and you probably already know this. I'm just reminding you. If the angle measure is followed by an S, then that means that it's in the southern hemisphere. It's down here. Okay, so that's just what those mean. Northern hemisphere, southern hemisphere. We use 3,963 miles for our radius of the Earth. I actually will probably put the number in maybe one of the questions, when you're quizzed on this. It's a good number to memorize, but I don't want you to miss the problem because you don't remember that particular number. But we use it all the time, 3963, that's the radius of the Earth. I'm not going to put it in every single problem, but I'll just put it somewhere on the page so at least you have access to it if you don't remember it. So that is the number that we're going to use on these applications. And then the third thing that we're going to talk about today is linear speed. Linear speed. So we have a formula that goes with that. Linear speed is many times designated with the letter V, velocity. That's normally what we use for linear speed, would be V, which stands for velocity. And the formula basically is the distance you travel divided by the time. Okay, so this is a great formula. Like if you're going on a road trip, and I know this is kind of nerdy, but I have done this before. You probably can't believe that, but yes, I have. So if you go on a trip, let's say you've traveled 450 miles, and you did that in however many hours, I would calculate what the average speed was. I mean, how fast are we going average? I mean, it seems fun. Yeah, maybe something you could try. So it works. Well, what we're doing, the application that we're using it on today actually has to do more with arc length than it does with just straight distance like on a road. We're going to be looking at this kind of distance, the distance of an arc length. So this is the formula, but instead of D for just kind of a standard distance, we're going to use S, which means arc length, because that's the application that we're using it in. And we just learned that arc length, the S, is the same as R theta. So this is the formula that I'm going to be using, R theta over T. Just because of the application that we're working with. All those formulas are accurate. I'm just going to be working with arc length. So this is the formula that I'm going to use in our problems that we're getting ready to do. So any questions on the concepts so far? Okay, well let's jump into the problems, the applications. So this lesson requires a calculator. Hopefully you brought yours with you. I should have reminded you yesterday or let you know. Sorry about that, but hopefully you just have it with you. If you don't, when we get ready to do our daily work, you just put your name on the board, and you can. I have a couple of calculators. You can just borrow one of mine, but we'll deal with that when we get to daily work. All right, so let's go and look at our examples. So the first example that we're going to be working with is on arc length. We're told to find the radian measure of the central angle of the circle of radius r that intercepts an arc of length s. Okay, well, I am all about drawing pictures. I'm very visual. It helps me to understand what I'm doing. What does this mean? Intercepted arc. Okay, I'm drawing this exaggerated so that you understand what an intercepted arc is. This part right here, and I think once you see that the angle measures, those sides have been extended, you can see why they call it the intercepted arc. You with me? So that's why they call this the intercepted arc, because if you were to extend the angle lines, that would intercept that arc. So we have find the radius. So we have central angle, blah blah blah. So r, we know r. R is 80 kilometers, and we actually know our arc length. Arc length is 150 kilometers. So I always start by just writing down the formula. Why try to do things from scratch? Just write the formula down and figure out where things go. So the formula we would have memorized by this time is arc length equals r theta. All right, so we have our arc length, which is our 150. I'm going to leave the units attached to it just because we're in an application and we may have to do dimensional analysis. So I'm just going to keep them there to make sure everything is okay. Do you have to? No, you don't have to put them there if you don't want to. I'm just going to keep them there to help. So that's our arc length. Our radius we know is 80 kilometers. And theta is what we're solving for. Okay, so I have filled in my formula. Now I'm simply going to solve for theta. So I have 150 kilometers over 80 kilometers. Look how those units cross out. And that brings us to the beautiful thing about radians. Radians are the only unitless measure. They do not have a unit. It's just a radian. So the zeros go away, and so my radian measure is 15/8. Now you could write radians if you really want to, or sometimes abbreviation rad sometimes, but you don't have to, right? We talked about that before. If there's no degree symbol, we know it's a radian. So that is how many radians we have, because that's what they're asking for. Now if they ask for the degree measure, that would be okay, right? We would just have to do it one more step. We would just have to translate this into degrees and then we'd be done. Okay, but they actually were nice and they asked for the radian measure. Okay, any questions on that problem? Okay, let's go to the second one. This is one that's going to involve our latitude. So we have Beijing, China is due north of Perth, Australia. And it gives us the latitude of Beijing and of Perth. About how far apart are the two cities? Well, I'm going to draw. Okay, now I'm not a great artist, so just kind of bear with me. I'm just going to draw a circle, make it try to look like the Earth. So we'll just, best we can. It's kind of, yeah, it's going on. All right, so there's our Earth. It tells us that Beijing is in the northern hemisphere. So I'm going to indicate that. This measurement means that's the central angle. That is the central angle measure from here, from the equator to Beijing. This angle measure right here. We'll just do a different color. So that angle measure is 39 degrees 55 minutes. Okay, that's what that is. So that's going to be important for us in just a moment. Now we have the latitude of Perth. That's in the southern hemisphere. So it has an S on it. So that's going to be down here. So that's Perth. And it's latitude is 31 degrees 58 minutes. So here we go, right here. Right there, so 31 degrees 58 minutes. Okay, so now let's see what they want. About how far apart are those two cities? Well, what they're really asking for in kind of a, strange way is this arc length. Right? That's what they want. They want that arc length. So we're going to use our arc length formula to find that. Now, I've had students ask me before, is it okay if I find this arc length, the arc length from the equator to Perth, and then the arc length from the equator to Beijing, and add them together? Yes, you can certainly do that. I think it would take a little bit longer, but it's certainly a viable technique. I'm going to go ahead and add those angle measures together so that I just have to do one computation instead of two. So let's add those together. So we have 39 degrees 55 minutes plus 31 degrees 58 minutes. We add that together and we get 70 degrees 113 minutes. I'm kind of glad it came out this way because if our answer was this degree measure, it wouldn't be in proper form, right? Because we know we have 60 minutes that we could turn into a degree, don't we? We have 60 minutes. We don't have 120 minutes, but we do have 60 minutes that we could turn into a degree. So I'm going to rewrite this just in a bit of a simplified form. Do you have to? No. I mean, that's not our final answer, but I want to go through the process. So we have 71 degrees, and then 113 minus 60 is 53 minutes. So that's my angle measure. That's that total angle measure. All right, so let's write down our formula. So we have arc length equals r theta. So our arc length is going to be r is our radius of the Earth, right? R, that's this portion, versus the 3963, 3,963. That's the radius of the Earth. Our angle measure is this right here. Now I'm going to be using a calculator. I'm going to be inputting that in a calculator. So I'm going to just write it like I would put it in a calculator. 71 plus 53 over 60. Okay, so that's the angle measure. But that's not enough, is it? That's in degrees. To use this formula, I have to be in radians. So I'm going to have to multiply this by pi over 180. So what I'm showing you is the work that I need to see on a quiz or a test. What do I need to see? I need to see your formula completely filled out like this. Then you can just put it in your calculator and give me the answer. Okay, but I need the formula filled out. So we fill out the formula, we put all that in our calculator, and you should get 4,971.983 miles. That's how far apart these two cities are. Okay, so let's talk about decimal places and such. Our standard mode of operating is the thousandths. Why? Well, that's because that's what it is in calculus. That's what the AP test requires. The standard measurement is in thousandths. If you round to hundredths, you will lose the point. Okay, so we're going to keep, I'm training you early, right? This is great because I spent a whole year training my calculus students about that, and I still have students that don't round to the thousandths. It's like, oh my gosh, you just lost a point. Round to the thousandths. Okay, so we're going to round to the thousandths unless otherwise indicated. We also have to read directions. If the directions say something different, we go with the directions. If the directions don't say anything, we do thousandths. That's just what we do. Okay, that's the procedure. So we know what to do. So we're on the thousandths. Now, rounding versus truncating. Do we know what truncating means? Right, it was cutting it off. So let's say, for instance, this was 4971.9827. Okay, let's just say. I don't remember what it was, but let's just pretend. Okay, if we truncate, we would just chop that part off and ignore it. You are allowed to truncate on the AP test. So I will take either one. Truncate, just cut it off and just forget about it, or round, which the 2 would turn to a 3. Okay, does that make sense? So you can do either. You can truncate or round, whatever you're comfortable with. Okay? All right, questions on number 2. All right, let's move to our last problem. The last one, we have the second hand of a clock is 10.2 centimeters long. Find the linear speed of the tip of the second hand as it passes around the clock face. Okay, so I'm going to have to draw a picture. Of course I am. So here we go. Here's my clock. Here's my second hand, which of course we're tracing the speed of the end of it, the tip of the second hand. 10.2 centimeters. That's what we have going on. So linear speed, we just write down the formula, right? I encourage you just write the formula down and then figure out what goes where. R theta over t. Okay. So I think our radius is pretty straightforward. We know that the radius is going to be 10.2 centimeters. So our velocity is going to be 10.2 centimeters. And I'm just keeping the unit in there because I want to. Do you have to? No. It's up to you. The angle measure. Let's think about this for a second. I really could choose any angle measure I want. Like if I want to think about this second hand going around half of the way, I could do that. But I would have to adjust the time accordingly. Whatever you do. So I'm going to keep it easy on myself. And I'm going to say it goes around one time. Why? Because if the second hand goes around one time, that's 1 minute. Easier for me, right? But again, it's your choice, whatever you want to do. So I'm going to make it go around one time, and one time around in radians would be 2 pi. So my angle measure is going to be 2 pi. So now that affects the time. Since I'm having the second hand go all the way around once, then I know how long that takes, right? Because this is a clock, right? It's a clock. So if the second hand goes all the way around once, then that's 1 minute. Now, since the problem did not indicate whether we needed our answer to be in minutes or seconds, we could choose. For whatever reason, I chose 60 seconds. You could choose 1 minute. We just need to put the units at the end, right, so that we can compare our answers. Either is fine in this problem. So we get our calculator, we multiply that all out, and we get 1.068 centimeters per second. Now, if you wanted to use minutes, then you would have 1 min down here, right? 1 minute, and you would multiply this out, and you would have centimeters per minute, since you have a choice. And if you wanted to go crazy, like, you could maybe do on hours, or I mean, you could just go crazy with this, right? But I don't encourage you to go crazy with it. Actually, on a quiz or a test, I probably will tell you what unit I want, so that you'll have some guidance there. All right, questions on that? Okay.